In this video, we're going to look at this review for test number 2. The main idea of this video is just to point out certain common mistakes that students make with problems. So this first question is asking for the distance between these 2 points. So, various common mistakes. Number 1, students mix this up with the formula for midpoint. So be careful. It says distance, not midpoint. Now, the distance is from the distance formula, which is this. And students sometimes come into the test not knowing the formula, or they think they know the formula, but instead of having minuses here, they put pluses, or instead of having a plus here, they put a minus. So another mistake is having the wrong signs on the formula. Another mistake is, those are, I guess, major mistakes. I guess I'll give you one other mistake. When you're doing this formula, eventually you end up with something squared. Let's say you end up with 7 squared and you end up with another square. Let's say you end up with 5 squared. Students think that the square root cancels the squares. They think those cancel, and that would give you 7 plus 5. It does not work that way. You can't do that. So you'd have to do all the math to get the answer. Okay, the next one. It says y as a function of x, but we've always just called that being a function. So this is asking, is this thing a function? That's what that's asking. I don't really have more to say about that one. Here we're finding the domain. Be sure you know how to find domain, and there's basically 2 types of domain we have at this point in the course. One is when you have a square root, and the rule for that is you take the inside and you set that greater than or equal to 0, and whatever that answer is your domain. The other one is the domain for fractions, and that works differently. Be sure you know which one you're supposed to use, which one of those domain rules. Okay, find the equation of a line passing through 2 points. I highly recommend, as has been mentioned, that you do it this way, using this formula, and not do it another way that you may have learned elsewhere. You do what you want, but the people who I see do it this way get it right more often than the people I see do it the other way, even though the other way works if you really know what you're doing. Finding the center and radius of the circle. I think most people tend to get the center right. It comes from the opposite of that and the opposite of that, so it would be -1, +6. But I think they sometimes mess up the radius. Let's see, -1, +6 was the center. The radius you get by square rooting that, so the radius would be 8. Just be careful and be sure you've got that down correctly. Domain and range, don't really have anything I can think of to say about that. This one here, the graph, if it's x equals a number, then it is a vertical line going through that number. And the most common mistake I see with that, besides people just having no idea, is they think it is a horizontal line going through that number. Be sure you find a way to remember that it's a vertical line and not a horizontal line. Okay, even, odd, or neither. It is not all uncommon that students come into the test and they don't know the rule for even and they don't know the rule for odd. The rule for even is that f of x must be equal to f of -x, and the rule for odd is that f of -x needs to be equal to -f of x. If you don't know that rule, then it's very possible that you will miss the question on a question on the test that comes from that. Be sure you know those rules. Graphing a function. Nothing in particular comes to mind about that. Just be sure that you know what you need to know there. Finding the inverse. So the first step to doing the inverse is to write that as y equals. The fact that you have an x in the denominator, that messes up people a lot. Be sure, to make a long story short, just be sure that you know how to find the inverse of something that looks like that. If you don't be sure that you know how to do that with no help, then you may very well come in the test doing it wrong. Okay, this one here, you need to know how to do this by completing the square. So this involves completing the square. That's the trick that will allow you to do that. Be sure you know that. Okay, this one here. One mistake the students make is the following. They're asking, for instance, for a relative maximum. I know also a relative minimum, but don't worry about that at the moment. So you have a relative maximum there. You can tell the x coordinate is -2. The question is, what is the y coordinate? And students get stuck with that. And I understand. But the y coordinate comes from the fact that you know this formula for the graph. So to find the y coordinate of that point, you would simply plug -2 into that equation, and that would give you the y coordinate. So that would be your relative max, and then your relative min would be this other point right here. Again, you know the x coordinate is 2, and the y coordinate you would figure out by plugging 2 into that. Okay, composition. I see lots of different errors that people make with this. I highly recommend, if you're watching this video, that you actually find the composition of those two and see that you know what you're doing. And then check your answer against the answer in the answer key. And if you get it right, then it looks like you probably know what you're doing. And if you get it wrong, you need to find out why. Don't know that I have much to say about that, but I will say students sometimes forget how to find x-intercepts and y-intercepts. One way to find x-intercepts is to plug 0 in for y into the equation, and to find a y-intercept, one way is to plug 0 in for x into the equation. So be sure you know that. Okay, the domain here. Well, the domain here involves two different rules. It involves the rules for square roots, and the rule for square roots is take the inside set it greater than or equal to 0. It also involves the rules for fractions. And the rules for fractions say you need to see what makes the denominator equal to 0. The answer is in the answer key, of course, but be sure you know how those two rules combine for a problem like this one. Okay, graphing the function. Just be sure you know what all the standard graphs look like what does the graph of x cubed look like, what does the graph of x squared look like, what does the absolute value look like, etc., etc., and be sure you know the rules. For instance, on this particular problem, the graph of x squared is a u, and adding 2 would bring the u 2 units upwards. Okay, this one here, you need to know how to take the center of the circle and the radius and come up with the equation. I think I'm just going to do this for you. It's going to be x. Next to the x is the opposite of the x coordinate. Then you square that. Then there's a plus, which students sometimes forget. And then there's a y, and next to the y is the opposite of the y coordinate. And you square that. And that's equal to the square of whatever the radius is, and the square of that would be 19. So that would be your answer. Okay, this one here. One mistake the students make is they don't realize this is going on forever, and this is going on forever in those directions. And the way we know that is, basically the graph is sticking out there, meaning it goes forever. Even if it wasn't, we really try to put a little dot on the end if it's actually stopping at a certain spot. Since there's no dot, that means it's going on forever. This is a long story, but just be sure you know how to graph piecewise functions. Again, you're finding domain. Since it's a fraction, you should know the rule is to set the denominator equal to 0, and you should know what to do after that. This idea we discussed a moment ago. Again, be sure you know what the graph of the absolute value looks like. You need to know how to find the inverse of a function. The inverse of a function basically is step 1, write that as y equals. Step 2, swap the x's and y's. Step 3, which I'm going to leave to you, solve that equation for y. In other words, get y by itself, and you will have found the inverse. The midpoint. One common mistake with midpoint is they mix up the formula for midpoint with the formula for distance. The distance formula looks something like this. I'm just leaving out parts of it. So don't use the distance formula. It says midpoint. Another mistake is not knowing the formula or not knowing it correctly. This is the correct, oops, no it's not. This is the correct formula for midpoint. Another mistake is, well, a mistake with the formula is students sometimes think there's a minus in that formula. Those are pluses, not minuses. Another mistake is you're finding midpoint. Midpoint means you have a point, you have another point, you're looking for the one right in between. That is a point that you're looking for, so the answer should be a point. So sometimes students know how to find the coordinates. Let's say the midpoint of this was, and I'm just making this up, but let's say this was, the midpoint of this was 5, 2, which it's not, by the way. Students will sometimes say the answer is 5 and 2. No, it's midpoint, the answer is a point, so you need to write it like that to indicate it's a point. This is the same as saying the equation y equals 4, and as I mentioned earlier, if it's x equals, it's vertical. If it's y equals, it's horizontal. This one here, you can actually ignore, so don't worry about that. This one here, when you're finding domain, as far as we know at this point in the course, if you do not have a fraction, and specifically a fraction where the denominator has a variable in it, and if you also don't have a radical, then the domain is guaranteed to be negative infinity to infinity. I hope you know why, but basically that's the simplest way to say it. If you don't have a fraction with the variable and denominator, and you also don't have a radical, your domain is that, which is also called all real numbers. So that's what we have in that particular situation. Here we're finding the inverse. It's the rule I told you a moment ago. Let me go back to, where was that? Back to here, same rule I told you over there. Be sure you know how to find the inverse, especially when there's a fraction that you're finding the inverse of. Students think they know, and then they end up doing it wrong. So be sure you practice that and get it right. This one here, be sure you understand how to plug that in. Sometimes students say there's more than one answer. This is a function. It only gives you one answer when you plug a number into it. The answer to this one actually is -8 if I'm doing it correctly in my head. And hopefully you understand how to do that and you will do it correctly. Okay? Be sure you know how to solve something like this. I think some students think, oh, that's a difficult problem and he'll never ask that. It's often asked on test number 2. Be sure you know how to solve something like that. This I discussed a moment ago about even and odd functions. This one here, I don't really think I have much to say, so I'm just going to ignore that. This is similar to this one right here. Same idea. Just be sure you know how to do it. Be sure you remember for perpendicular lines, which is what we have here, the rule for slope. There's two things you need to know about the slope for perpendicular lines, so let me mention that. So suppose you have two perpendicular lines and the slope of one of them is -3/2. The slope of the other one would be positive, because for perpendicular lines, slopes are opposite signs, and it would be 2/3, because you also have to take the reciprocal. So don't forget for perpendicular lines to change the sign and to take the reciprocal, to do both. This you can ignore. You don't need to know that. This one here, be sure you know how to graph the square root of x. Be sure you know what the negative in front does. Be sure you know what subtracting on the outside does. This is section 3.4, if my memory is correct. Students do things like this wrong. The first step to doing this would be to do x minus 2 squared minus 3. You should know that. You should also know how to square x minus 2. And squaring x minus 2 is what you would get by doing x minus 2 times itself. Seems to be a lot of repeating at this point. So I think I'm going to stop this video with that. But of course, you're always welcome to ask questions. So that is the end of this recording.